I'm sorry, there's nothing I hate more than lots and lots of algebra, but let's go do this one. This is nice to meet you. I'm your auntie, and I have never met you, and kids usually hate me because I'm the math teacher. But here we go. You've got this cuboid, which is we just call it a rectangular box. And it says that the surface area of the cube is the same as the surface area of the cuboid. The surface area of a cube is going to be 6 times p squared. I think they have that at the beginning of the problem. Let's go look. Right here, they tell you 6p squared, and it just comes from adding up all the sides. But the area of the cube is going to be 6p squared given, but also you can derive it. We're going to have to derive it here. That's why I'm not getting bent out of shape about it. But here you have to do it yourself. So you have 2 sides, this dark shaded side and what's behind it are going to be the same. So the surface area of the cuboid is going to be, oh, I can't spell this. It's 2 of the dark shaded faces because I have a front and back of the box. So that's going to be 2 times the area of the dark shaded P where my cursor's sitting here. The base is going to be P minus A, and the height is going to be 10. How do I know the height is 10? Well, the height is given here. So this height here is going to be 10 centimeters. So I'm going to put 10 here. This is 2 sides, the dark one. And then you have the P plus A is the width of this front face, and the height of this front face is 10 centimeters. So I have 2 of those because there's a front of the box and the back of the box. So that's PA times 10. There's 2 of them, so it's 2 sides like this. And then I have the top and the bottom of the box. Across the top is P plus A. That's the width. And this way over here is P minus A. So all of these are length times width, and there's 2 of them. And so I get a total top and bottom. And so the total surface area of the cuboid is going to be this ugly mess, which is 20 times P minus A, that's this part, plus 20 times P plus A, that's this part, plus 2 times P plus A times P minus A. All right, and so I'm given that this amount is equal to 6p squared because the area of the cube and the surface area of the cuboid, so I should put surface area, are equal. So I'm going to put here that the 2 things are equal. Okay, so I go to the problem and they say you're supposed to get this animal 2p squared minus 20p plus a squared equals 0 after simplifying this god-awful beast. So let's see if we can sneak some stuff here out. I'm going to pull, so I'm a lazy mathematician, so I'm going to try to pull something here. See the 20 here and here? I'm going to pull that out. So I get P minus A plus P plus A and see if something drops out. This is a bookkeeping problem, which is why I'm not a fan of these things, but the A's drop out here, so that's pleasant. We have some pleasantness here. And I get P plus P. I'm just going to leave that here so you can follow my work. And then that's equal to 20 times 2p. And that's equal to 40p plus 2p plus a times p minus a. And I'm going to continue this on the next side. So I'm going to just take this and bear with me. I'm going to take this whole chunk here and I'm going to copy that. And I'm going to go to this next page and paste it up here. So there's that work again. And I'm going to have to Mr. Smiley these guys over here, or this is the difference of squares. So now I really have 6p squared on the left side, and on the right side I have 40p plus 2 still on the outside, but I get p squared minus a squared. You can either FOIL this out, Mr. Smiley or whatever you call it, see Mr. Smiley right here? Or you could just remember that this is the difference of squares. So I have this beast. It's looking a little better. We're getting better. And now the equation that they have in the first part is everything's over on one side. So now I'm going to change colors like a chameleon. And we're just going to take this 40p over to this left side. And I'm going to take the minus 2p squared over to the left side. And this is a plus right here, negative. So when I add it over, I'm going to get a 2a squared and set that puppy equal to 0. Now, after I have this, I see that I get a 4p squared if I combine these two like terms. So I get 4p squared minus 40p plus 2a squared is equal to 0. And now I'm going to divide everything through by 2. So if I divide this guy by 2, I get 2p squared. Divide this guy by 2, I get 10p. And over here, I get a squared is equal to 0. Oh, 20, sorry. I'm terrible at arithmetic. Okay, so now I got the same equation they have. Yay! All right, so that's the first question that they asked in part D. The next question. Oh, your pages are out of order. I combined it. The next question, as mentioned in part 1, if the surface area of the cube, I get this equation over here, blah, blah, blah. But then by using the discriminant, find the largest possible whole value number that A could take on in this context. Okay, so they want me to solve this equation using the quadratic formula. That's the discriminant. So the next step is, discriminant sounds scary. What is that? So I have to show you my notebook. What is that? Well, it's the negative, it's the value here, and then it's going to put quadratic formula, which has an a in it. But really what you're looking at is the coefficient here is your a, and the coefficient here is your b, and this guy whole is a constant, so it's c. And if you remember quadratic formula, so this a over here in blue is not the same as the a in green, but the solution to an equation like this, where p is your x, is given by negative b. So b is minus 20, so negative 20, the negative of negative 20 is 20, plus or minus the square root of the b guy squared, so that's 20 squared, minus 4 times a is 2, times c, which is a squared, and that's all divided by 2a, which is, it's not the same a, it's the blue a, so that's 2. This guy in here has to be a real number, so that means that the guy inside has to be non-negative. That's what they were after. So you'll take this guy, I'm just going to copy this to the next page. So copy, next page, paste. If I take the discriminant, which is the inside up here, let's change colors. We got 20 squared, oh, no change colors, minus 8a squared has to be bigger equals 0 for this thing to work out. And for that to happen, 20 squared has to be greater or equal to 8 times a squared, which means All right. Calculator, because kids today can't compute things. That's 400 divided by 8, of course. And that's 50 if I divide both sides by 8. That's greater, has to be greater or equal to a squared. And that means that a, if I square root both sides, a has to be smaller or equal to 7. If a is positive, if a is negative, it has to be smaller or equal to -7. But a is a something, let me see what a was again. You start to forget, but let's go back and look at what a was. I guess a could be negative. So I guess I get here, or a has to be smaller or equal to -7. So what it is, I'm not going to go into the graphics of this. So that's how you do it for that particular problem. Let's go see if I've answered everything they want. I think that's all you gave me. For that particular problem. So I believe that's all you asked me on that particular problem. So the values of a would have to be, let me see, they're out of order, which is why I'm having trouble. Oh, they want the largest whole number. I got 7.07 here. So that means the largest whole number, if it had to be, a had to be smaller than this, it'd be 7. That's the largest whole number. And then it says to use that value of a to go back and find the dimensions of the cube and the cuboid. So the cuboid is this thing here. Oh, actually, they want you to actually throw in 7 into this equation and solve for p. So you'd go back up to the top. You already did the math. Go back up to the top and say p is equal to 20 plus or minus the square root of 400 minus 4 times 2 times 7 divided by 4, and figure out what this guy is. And you can't see what I'm writing, but that's what I'm doing. I just put a equals 7 back in there, and I get I'm going to do this on Excel because I don't want to deal with this. So let's do this on Excel. Square root of, you can type this out on your calculator. And it says P is about 9.6. And then if P is 9.6, going back to the picture that we had on the cuboid, My dimensions on my cube are 9.6 by 9.6 by 9.6, and the cuboid would be, that's the sides of the cube, and then sides of the cuboid would be p minus 7, p plus 7, and 10, and that would be 9.6, so we'd go 9.6 minus 7 by 9.6 plus 7 by 10. And I don't want to add that. You can add that. You probably know how to add, so I'm going to leave that alone. So that's this terrible problem done.